geometry bag again. And the first topic is polygons, introducing polygons. You have learned about them, the main properties and main formulas about the polygons, as I know. Yes, in the primary school, you have learned something. Yes. Here you have the definition. I don't want you to write the definitions. You have them in the book, but which ones you want to note, you know, for yourself, you can write on your notebooks, or if you are writing, I don't know, but take some notes about the words, the terminology that we are using. A polygon is a plane figure that is formed by 3 or more coplanar line segments such that these are, look, these are the polygons, and these are not, I think. Okay, so polygons are, for example, triangle is a polygon. This quadrilateral, we call it quadrilateral, it's a polygon parallelogram. Also, this one is a polygon, this one is a polygon. You may have with 6 sides, you may have with 7 sides, doesn't matter, but these are all polygons. Polygon, lots of sides, it means polygons. For example, here there are the main elements of a polygon. We have sides, as you know, these are AB, BC, CD, DE, EA. They are the sides. And we have vertices, the points. One of them is called vertex. Plural form is vertices. And we have the interior angles here. Okay, you can draw this one. You can draw this figure for you to know what we are talking about. I think that you know most of them, but again, to remember, polygons. Also, you can take with the book with you to take some notes there maybe. Okay.
Teacher, we should also draw this convex polygon.
The convex polygon and concave polygon, I mean, if you will understand, it's not a problem. But the things, these ones, I want you to write to know the main elements that we'll talk about: interior angles, vertices, and the sides. Only that one.
Teacher, what is vertices?
The points. You know, in the, do you remember in the...
Oh, okay.
Triangles we were talking about?
Yeah. Yes, teacher, yes. No, I didn't know.
So here, how we call it convex polygon, how we call it concave polygon. Here, look, all the sides and the vertices are like outside of the polygon. So this is the interior part of the polygon, and this is the exterior part of the polygon. So all the vertices are like outside of the polygon. But here, can you see that this one, it goes to inner part. Because of that, this one is called concave polygon. This one is called convex polygon. Okay.
It's okay.
Interior, because the side, the vertex, one of the vertices, it goes like inside of the polygon. If it is okay, if you have drawn this one, I will continue.
It's okay.
And here one more time, these are the polygons, but these shapes are not polygons, guys, because this one, for example, here you have a arc, like it's not straight line, it's not a line segment. This is like an arc. Here, because it doesn't finish, it doesn't close itself, this is not a polygon. Also here, they intersect each other. the line segments also here, the same thing. Because of that, these are not the polygons. Now, here, the names of the polygons according to their sides, the number of sides. So if it is 3 sides, we call it triangle, we know it. If there are 4 sides, we call it quadrilateral, and mostly we'll use this name, quadrilateral. And with the 5 sides, we call it pentagon, hexagon, heptagon, octagon, nonagon, decagon, ondecagon, dodecagon, and if there is n sides, it's called n-gon. Okay, with the n side, it will show us n-gon. We don't know the number of sides. So these ones, nonagon, decagon, ondecagon, maybe we will not use that much, but this part, like hexagon, heptagon, octagon, we can see in some questions. If you know the Greek numbers, it's very easy to understand. Penta is 5, hexa is 6, hepta is 7, octa is 8. You have them also, these ones in the book. If you want, I can wait you to write, or I can continue to see the other parts.
Teacher, wait a little bit.
Teacher, just a second.
Okay. Let me open the attendance list at the same time. So
You can continue, teacher.
first lessons, as you know, first lessons are always with the names, definitions, and the words that we'll use, the terminology, you know. Then after that, we'll start the normal solving geometry.
You can continue, teacher.
Okay. Regular polygons. This name, guys, regular polygons, you will see in some questions. For example, the shape maybe will not be given, and it will say that the polygon is a regular polygon. What does it mean, regular polygon? If all its sides are congruent, equilateral, and all its interior angles are congruent, equiangular. So all the sides are the same of the polygon, and all the angles are the same of the polygon. So this kind of polygons we call regular polygons. So here it's given some regular polygons. For example, an equilateral triangle, because all the sides and all the angles of this triangle is same, it's equal to each other. So this is a kind of regular polygon. A square also is a kind of regular polygon. And here it's a regular hexagon. So when it will say a regular hexagon, we'll know that all the 6 sides are equal to each other, and all the angles, interior angles, are equal to each other. But these ones, for example, equilateral, but not regular. This shape, this, let's say pentagon, this is 5-sided polygon, pentagon, all the sides are given that it is equal to each other, but we don't know about the angles. Okay, they are not, for example, these two, if it is 90, the others are different. So this is not a regular pentagon. Also, rectangle, all the angles are same, but the sides are not. So this is not a regular polygon. And here all the angles are same, but the sides, because the sides are different, it is not a regular polygon. It's okay. Did we understand what does mean regular polygon? All the sides,
yes,
the angles has to be
same. And angles are,
yes, both of them at the same time. I'm continuing to the next one. Okay.
It's okay, teacher, you can continue.
Okay. And here the 5th one, diagonals of a polygon. Do you know what does mean diagonal?
No. Yes.
A diagonal, I think that it's same in your native language, diagonal.
Macedonian is the same, diagonal.
Yeah, the line that crosses from
one vertex to another one that is not, how to say, adjacent, we call it adjacent. For example, not A to B, this is side, but from A to C, there is another vertex between them. From A to D, from A to E, these are the diagonals. A diagonal of a polygon is a line segment that joins two non-consecutive. These two are consecutive. These two are consecutive. So A and C, they are not the consecutive vertices. So this line that joins these two non-consecutive vertices are called diagonals. Okay? So for example, here, only from the vertex A is drawn. You can draw from vertex B diagonals, from vertex C, from all the vertices, you can draw the diagonals. Okay, did we understand diagonal? For example, from
But teacher, shouldn't it be the same when you symmetry them? Or not?
what you mean, symmetry then?
When you fold them, teacher, they are the same, equal in all sides.
No, only one of them, for example, it is like that, in this shape, not in every shape. It's not.
Ah, okay.
Okay, but the important thing is diagonal is, for example, if I have a square, I will try to draw a square. So from this vertex to this one, this is a diagonal. And from this to this is a diagonal. Okay, but here you have more diagonals because it is a 6-sided polygon and you will have more vertices and you will have more diagonals. Okay. It's okay, guys?
It's
It's okay, teacher.
Okay. And here, there is a property about the diagonals. In a polygon with n sides, the number of diagonals is n times n minus 3 over 2. So here, guys, this formula will give us how many diagonals we can draw in a shape, okay? For example, how we are using, you need to know this formula, by the way. What we are doing, find the number of diagonals in a heptagon. Heptagon is given here, that is a polygon with 7 sides. So this 7 is n. N is equal to 7. It's given us that n is equal to 7. Find the number of diagonals. What I will do, the formula is n times n minus 3 over 2, which will be 7 times 7 minus 3 over 2. And it will be 7 times 7 minus 3, it is?
It's 4
Over 2. I can simplify 4 and 2. It will be 7 times 2, 14. So we have diagonals in a heptagon. Okay? It's okay?
Yes, teacher.
While you're writing this one and solving the others, let me take the attendance, not to forget. Yusuf is not. Anita?
I am here, teacher.
Okay. Alexander?
I am here.
Okay. Eva? No. Elsa?
Here, teacher.
Okay. Amran?
I'm here.
Rona?
Here.
Okay. Stephanie?
Here.
Okay. Fatih?
Here.
Okay. Kibariye?
Here.
Okay. Singa?
I'm here.
Okay. Ardita?
I'm here.
Okay. Arta?
I'm here.
Giovanna?
I'm here.
Okay. Vesa? Vesa? No? Stanislav?
I'm here, teacher.
Alman?
Here, teacher.
Okay. Rumeysa?
Here.
Okay. Sarah?
I'm here.
Okay. Ermal? Is not. Hamza? Is not. Besan?
Here, teacher.
Okay. So how we'll find the number of diagonals in a nonagon, Kibariye? What do you think? Nonagon. It's given here that it is 9.
We will do 9 times 9 in parentheses 9 minus 3
9 times 9 minus 3
over 2
over 2, yes.
is equal to 9 times 6
Yes,
over 2,
yes.
and we have 36, no,
One
54
more.
over 2.
I-
We have 54 over 2.
54 over 2, yes. And this
And that will be 27.
27, yes. So in a nonagon, we have 27 diagonals. The same thing you will do with a 15gon. Find the number of diagonals in a 15gon. You will do the same thing. When the number of sides is given and it's asking for the number of diagonals, it's very easy. Directly you will use the formula and the result will give you the number of diagonals. Here, another question we have, a polygon has 14 diagonals. How many sides does it have? Here, the number of diagonals is given. We need to find how many sides does the polygon has. So what do you think? How we'll do this?
Teacher, we will write the formula and we will equalize it with 14 and then we will find them.
Yes, so we have the formula. We know that this formula gives us the number of diagonals. And if the number of diagonals is given, this formula is equal to that number, 14. And now we can solve this one. What we have, firstly, you can do the cross product. N times n minus 3 is equal to 2 times 14, which will be 28.
28.
So when I will solve the parentheses, what I will have, n squared minus 3n is equal to 28. So we have our beautiful quadratic equation. And n squared minus 3n minus 28 is equal to 0. And my dear students who have studied everything about quadratics,
Teacher, whatever we study quadratic pops out of nowhere.
one more time.
Whatever we study, a new chapter quadratic pops out of nowhere. It's like,
Yeah,
boom,
I
I'm
said,
here.
I said to you, after this, when you finish the quadratics, after this, everywhere, you will see it somehow. As you see, in
Teacher,
geometry, we have the quadratics, yes?
teacher, why don't we do n1 is equal to 28 and n minus 3 is equal to 28? Wouldn't it be easier to find?
One
Because
more
now
time.
with quadratic. N1, teacher, from the first one, not before doing it quadratic.
This one?
Teacher.
This one, you mean?
Yes, from this. Can we do it? Yes.
What to do?
N1 is equal to N1 is equal to 28 and N2 is equal to 28 plus 3. We
So
cannot do it.
if you will
like that.
say that n1 is equal to 28, and then you are saying that n minus 3 is equal to 1, because 28 times 1 will be 28. You need to find here the factors of 28, and there are lots of to find. You can do it like that. But we know the easier way. N, N. And this is 3n, and here I have 28. So it is
7 and 4, minus 7 and 4.
7 and 4, because we have minus here, 7 will be minus. So n1 will be 7,
And then 2 minus 4.
minus 4. Because we are in geometry right now, and n is a number of sides, so it cannot be negative. So only the solution is 7. Okay. So a polygon, this polygon has 7 sides. Okay. Did you understand?
It's okay.
Okay.
Yes.
Okay. Are you writing?
I took screenshot, teacher. I will write after lesson.
Okay. So I'm continuing to the next one. How many minutes do we have, Alexander?
We have 9, teacher.
9. Okay. So here we have some more questions about the number of diagonals. An octagon. What is octagon? Which one is octagon?
With 8 sides.
With 8. So Tringa, how will find how many diagonals an octagon has? Do you remember the formula?
Teacher, the formula with n, right? The previous one.
Yes.
N times, we open the brackets, n minus 3 over 2.
So here in A, what is our n? Octagon.
Fine. Octagon 8.
8. 8 times.
Okay, 8 times 8 minus 3
Yes. Over.
2.
Okay. Then
8 times 5
8 times 5 over 2.
over 2. 40 over 2.
40 over 2.
20.
20. So an octagon has 20 diagonals. Okay, the same thing you will do for this decagon. Alexander, what is decagon?
What, teacher?
Decagon, what is decagon?
With 10.
With 10?
Yes.
Okay.
So it will be the same formula as the previous.
I'm writing the formula.
It will be 10 times 7
Okay.
over 2.
Okay.
It's 70 over 2, 35.
Oh, 70 over 2, so it is 35. Okay. And Stanislav, what about C?
I have no idea.
You have no idea, so let's do it together to have an idea. Okay? Stanislav? Okay, Stanislav.
Teacher, can I do it?
Yes.
My internet died. Let's do it again. What do we have to do?
Okay, we started with Stephanie right now. If you want the other one.
Okay, I'll do the other one.
Okay, Haydi. Haydi Stephanie.
Teacher, it will be n times n minus 3 over 2.
Yes.
Then it will be 15 times 12.
Yes, 12.
2, and then 180 over 2.
Okay.
And that will be 90.
That will be 90. Okay, thank you. Now, Stanislav, can we do it? The D together?
Yes.
Yes.
The same formula, I guess.
Yes, the same formula. I'm writing the formula again for you. Then we have here.
Thank you.
1 gone.
21. So 21.
Yes. N is 21, it means. 21 times 21 minus 3 over 2. Only instead of
2, yeah.
right, the 21. And then what we'll get?
21 times 18
Yes.
over 2.
Okay. You can do some simplifications or you can do directly the multiplication here. Which one you want?
Do the simplification, teacher.
Okay.
So we get
So
21
Wait,
times 9.
yes. So 1 times 9, it's 9. 2 times,
189.
yes, 189. Diagonals has 21 gone. Okay, so did you understand? Do you have an idea right now?
Yes, teacher.
Okay, great. Thank you. And we have here another question, E. A polygon has 2 diagonals. Find the number of its sides. Can you say it directly, guys? Which polygon has 2 diagonals?
Teacher, it's 4.
4.
A square.
Yes, the polygons with 4 sides. How we call it? Quadrilaterals.
Quadrilateral.
Yes. So let's see what we'll have. 2, it's equal to 2, n square minus 3n is equal to 4. I will take 4 to the other side. Let's do it here. N square minus 3n minus 4 is equal to 0. So what we'll have here? N. Here I have 3, here I have 4. So it will be 4 and 1.
Minus 4 and 1.
Yes, well, one of them has to be minus
4.
4. Then we have n1 is equal to 4, n2 is equal to minus 1. Because it cannot be negative, minus 1 is not the solution. This is the solution. Or directly, we know that 4 sides of quadrilaterals has 2 diagonals. Did we understand the diagonals?
Yes. Teacher, can I ask something?
Yes.
Here, if you have 2 positives, what will happen?
You cannot have 2
If
positives.
we cannot?
No, because you know it's always here you will have the minus because of the formula. And one of them has to be minus, the other one has to be plus, and you will have one result negative.
Thank you.
Only one solution you need to have here. Because of that, you will not have 2 positives, okay? So if it is okay, guys, I think that we have 1 minute left.
Yes, 1 minute.
Okay, next lesson. We'll continue.
See you, teacher.
See you, teacher.
See you.
Goodbye.